Well, greetings everyone, and thank you for joining for another one of our partner webinar series. My name is Christopher Black. I'm a solutions engineer, and joining us is Jeremy Adams with Twistlock. And for those of you who don't know, Twistlock is an amazing company in the cybersecurity space. We're going to talk a lot about Twistlock. We're going to talk a lot about CircleCI Orbs. But quick round of introductions. Again, Christopher Black. Been with Circle for about three and a half years now. I'm a solutions engineer now, but my background is predominantly ops, DevOps, infra sort of stuff. So for the first 2 years I was here at Circle, I was on the SRE team. And then Jeremy.
Hey, thanks, Chris. Jeremy Adams with Twistlock. I've been here about 6 months, which already feels like a lifetime. I was previously over at Puppet in the DevOps space for about 5-6 years. And yeah, I'm really excited to work with Circle on this integration and this webinar today. So let's get into it.
Fabulous, yeah. So quick agenda to level set real quick. We've already covered introductions. We're going to talk a little bit about CircleCI Orbs and why should you care. We're definitely going to talk a lot about Twistlock. And again, Twistlock is a really amazing company that's doing some pretty cool stuff in the cybersecurity space. And then above all, we're going to talk about the Twistlock Orb that Jeremy and his team has authored. We're going to run through a live demo. And then, of course, we're going to save 10-15 minutes at the end for Q&A. All right, so orbs. What the heck are orbs and why should you care? So orbs are shareable templatized pieces of CircleCI configuration that you can share across N projects, right? So historically, every project, every CircleCI project had to have its own configuration file, and that configuration file lived in the root directory of a project's repo, right? And this was great, this worked fine. We use simple declarative YAML syntax, right? But you can think of orbs as kind of a package manager for CircleCI configuration, and being able to templatize pieces of that configuration and then share that configuration with other projects is immensely beneficial for any number of reasons. And this is just a quick look at what an orb might look like. So we can templatize the individual steps. We can templatize the executors, that is to say the execution environment in which we pull in code and run said steps. And then you can also templatize job declarations. And whilst not explicitly indicated here, you can also templatize workflow stanzas. What the heck are workflows? Oftentimes referred to in pipelines and other CI platforms, but effectively a workflow is just an orchestration of jobs that are connected together in some linear fashion, or not necessarily linear. In fact, on our platform, you have total control over the dependency graph and the relationship between the various jobs. And of course, orbs themselves are parameterizable. I hope I'm not making up words again, but you can totally pass parameters to the steps, the commands themselves, etc. And so a number of our technology partners, you see this is not an exhaustive list by any means, have authored a number of orbs, right? So you see Twistlock, Datadog, Percy, Hapo, and orbs are a really amazing way to facilitate third-party integrations with other awesome technology companies without having to reinvent the wheel. So let's get building. And I think with that, Jeremy, I'm going to pass it over to you.
Perfect. Thanks, Chris.
Pleasure.
Could you go to the next slide and we'll dive in first a little bit about what Twistlock is to orient folks, and then we'll get into this particular orb integration. So Twistlock at its core, we're a cloud-native cybersecurity company. We've been around about 4 years. We helped to define this space. And you use us anywhere in your software development lifecycle around cloud native. So think of us working with you in the build process, in CI with CircleCI, for example, where you're building container images or you're building serverless functions, things of that nature, or then you're shipping those artifacts off to registries or serverless repos, and you need to make sure that what was green a little while ago in CI is still green tomorrow or the next day, sitting there in that repo, that registry. And then also, of course, once you're running out in production, you need to continuously ensure that things are free of vulnerabilities or big compliance issues. And you also want to be able to manage the runtime behavior. You want to learn how things should run, and then you want to make sure that they're running properly and detecting anything that's outside of that. And of course, we work across the stack, right? Through all the different cloud providers, all the different sorts of platforms and container runtimes and orchestrators, and all the new stuff that's coming out around serverless and Kubernetes as a service, et cetera. So let's pop to the next slide, Chris.
Awesome.
And just a little bit about, again, I said that we've been around a while and been, in this space, helping to build this space out. So this is a little bit of that credibility about who we work with, used by about, a quarter of the Fortune 100, and the majority of the U.S. government cabinet level agencies and all branches of the DoD, where security really is important, of course. We also contributed early on code to Docker and OpenShift and Docker Swarm that allowed, that secrets management framework to get built out. So we helped build that. And then our CTO, John Morello, is one of the lead authors on the NIST special publication 800-190. That's the container security pub. So, really active in that community as well. And certainly we've been chosen by one of the largest cloud providers in the world to do the back-end scanning for all the containers sitting in their marketplace. And so again, just honored to work with companies like AWS and like CircleCI, and really gratifying. Go to the next slide as well.
That's awesome. And Jeremy, let me just interject real quick. CircleCI over the summer, as part of our commitment to federal customers, government customers and technology agencies within the federal space, we underwent an authorization called FedRAMP, right? And you can think of FedRAMP as SOC 2, but for specifically government customers. And a big part of our FedRAMP authorization was integrating Twistlock into our software delivery pipeline. So yeah, we're thrilled to work with Twistlock, and super thrilled to have Jeremy with us.
Well, thanks so much. Yeah, really appreciate CircleCI being a customer as well. And so this is, again, a little bit about the Twistlock platform itself, right? So I mentioned a little bit about the complete software development lifecycle. We can break that down roughly into build, ship, and run. And so we work with you across all of those different phases. We're going to focus a lot today, obviously, on the CI portion, so more on the build side, where we're going to be looking at vulnerabilities and compliance issues that could be cropping up, in our example, inside of an image, a container image. But of course, you want to keep looking out for those things all the way through those things sitting at rest inside of repositories or registries, as well as in runtime on hosts. We won't really focus today on our cloud native firewalling capabilities, layer 3, layer 7 there, or our runtime defense, where we use machine learning to learn what's good and then alert or block things that are bad, or our secrets management, etc. We're not really going to focus on those. We're going to stick to the CI side of things, which really is in keeping with the kind of shift left idea in DevSecOps today, right? Let's make sure that we're not shipping anything, even to a registry, right, that is not of a quality that we need in terms of security for our organization.
Well said.
Okay, let's, I think we have one more slide, maybe, Chris. Yes, architecture.
This is good stuff.
Yeah, this is a lot going on this slide, but I think it's helpful, right, to orient folks to what they're seeing and where things are happening when we're looking at the demo in a little bit. So the Twistlock architecture consists of, let's first start in the upper left with the intelligence stream. We gather over 30 different upstream data sources. Some of these things are open source feeds around OS or platform, but others are things that have to do, they're kind of boutique data sources that we work with providers on, or that we generate our own intelligence from our Twistlock Labs team in Israel. And through that, we're able to kind of aggregate, deduplicate, and curate all that information and have that consumed by our console component you see in the upper right. The console is just a container, so it runs natively in kind of cloud native environments. It's where, of course, you have the GUI, but additionally, it's where all the policy that you want to set, where that lives, right? So we're consuming all this new intel about the threats, the vulnerabilities that are out there in the world. You're able to set what's important to you. You can, of course, work with our APIs. Every click in the GUI is basically an API call. So if you want to do some other integration, pull in your own identity management providers, send data out to a SIM if you have one of those. And then that integrates, all that policy and all that intelligence integrates with the active defenders that you see in the lower right. Those are running on things like, a Docker or, container host for Kubernetes. And it could also be running just on a Windows or a Linux host machine, like a VM, for example, or it could be running in something like a serverless function or containers as a service. So
like Lambda, for example.
Exactly right. And then and that's what we do for, kind of all the active ongoing defense and how we scan a serverless repo, or how we scan a container registry. We use a defender to do that as well. But we're really going to focus today on, again, that first step in the life cycle that's all the way in the lower left there, the CI integrations. And we're going to be using, of course, our CircleCI Orb. It was a lot of fun to put together. And we're going to be encapsulating in there some behavior that uses our Twist-CLI tool. So Twist-CLI is kind of a Swiss Army knife that comes along with Twistlock. It's a static binary. You can, at any time, use the API to ask the console for a copy of it if you've got credentials. And then you can execute Twist-CLI to do local scans of all sorts of different resources you might have. Everything from PCF, Pivotal Cloud Foundry droplets, to containers, to serverless functions. You can do a whole bunch of things with Twist-CLI, but one of the things you can do is scan container images and for vulnerabilities or compliance issues. And so instead of you having to figure out how to run all that stuff and how to call those APIs, we've used the CircleCI Orb to wrap all that up and expose just a real minimal, simple API, if you will, interface that lets you incorporate this into your CircleCI workflows really, really easily. So that's what we're going to show today.
Awesome, awesome. Looking forward to it. And you said that the CLI itself is just a static binary written in Go?
Yeah, static binary written in Go. So have you been playing with Go at all, Chris?
I have been, yeah. I've got a couple of personal projects I'm building in Go right now. And then we also have a local CLI that you can use to validate your config file, run Docker images locally. And then actually we use the CLI to push orbs up to the registry, and that was written in Go.
Oh, right. I use that tool. Awesome.
Yeah, awesome.
Well, cool. I guess at this stage, should we switch over and I'll fire up a demo?
Right from here on out.
Cool. All right. Let me share out my screen. Perfect. And hopefully you can see some code.
Yep.
All right. We're in good shape. So I'm going to bop around. I've got a few different windows open, but what we're looking at right now is this is where we'll be coming back to. This is kind of, if you think of this as my repo where I'm actually doing my work, right? This is where I'm working on a project. In this case, it's called test image. But imagine you're working on your own project where you're building some container images, for example, and you want to ensure that before you push those things up to a registry or push them out to production, that those things are free of any vulnerabilities. I'm going to kind of step you through that process, but we're going to come back and actually use this here, make some edits to it. But first, we'll kind of start off at the beginning. So, when I started this journey, I went to CircleCI.com. I clicked on Explore Orbs, and I was able to see all these awesome orbs that were here, certified orbs from Circle, and also a bunch of partner orbs. And I was like, I want to make a partner orb. We want to really, get this going. And so, sure enough, here's our Twistlock Twist-CLI scan orb that we have. I've even got that one opened up here already. And you can see in here, I love the documentation that comes with these. It gets auto-generated. It was really, really easy to work with. Just push this up and get all these great docs. We added in here a link as well to the GitHub repo itself. So you can actually get in there and see where the orb lives. And if you had some issues with it, or had a suggestion, you wanted to work with us, love to hear from you here in this project. But over in the actual orb itself, you can, let me actually move my toolbar here for Zoom so I can click these things a little better. There we go. So over here, you can actually learn about how this orb is put together. And this is really instructive, given the primer that we got from Chris, to kind of see the different parts of the orb. So first off, we start out with a usage example. This is going to be how you would actually use it in a project. And it's going to be very, very similar to what you saw in my repo of my test image repo. Essentially, what you do is you just declare that you want to use an orb, or which orbs you want to use. Here I'm just using one orb, but you could use many orbs in conjunction. And then it's all about just defining some jobs. In this case, I'm going to define a job that will actually build my Docker image in this case. And then we're using an approach in our orb where we build that image and then we save it off into a workspace. So the idea being that, if I was running this all in kind of you could think of it as like a single thread, right? In a single environment, then in a single execution environment, I could execute a bunch of different commands, hit a bunch of APIs, do a bunch of stuff all in one kind of scratch space. But in the context of orbs, we're kind of passing to the orb different arguments that tell it what we want it to do. And the orb contains certain functionality. So in our case, the TwistCLI orb here, you can see we defined it as TwistCLI. The TwistCLI orb has a scan image function within it. And that scan image is going to take in certain parameters, if you will, that define, where's the image that we want to actually scan, and what are our thresholds for vulnerabilities and for compliance. And so that, because we're passing some things to it, we need a place where in the initial context where we build our Docker image here, and then we need a place where we can kind of stash that image that we've built so that then the orb can pick that up and do the scan for us and then return the results. So we actually are using a really cool feature that's built into CircleCI that's called workspaces. And so essentially what we do is we just build our Docker image. We then create a little place to put a save of that image. So you can use Docker save, for example, to save that image out as a tarball.
It's a tarball, yeah, which is, I think a lot of people, if they're not aware, they should be aware that you can save Docker images as tarballs. And then using a feature like workspaces, for example, workspaces are pretty awesome. They enable you to share and persist files between various jobs in a workflow, rather than pushing and pulling an image from a registry, every time you want to use that image again downstream in the workflow.
Exactly. And you certainly could do that, right? But then, if you want to have this flow where you're doing everything right here, in your workflow and don't have to worry about some external registry, you can use this functionality right here. And yeah, it's kind of, I feel like it's almost this like little secret passage, right? That goes between the different jobs. Where
it's a good analogy. And I like what you said though about just kind of conceptualizing it as a thread.
Yep, exactly. Right. So we need to basically pass this over to that other orb thread, if you will, right? And just let it know where it is and what it's picking up. So we're persisting it here to a workspace that I creatively named workspace. And we're telling it what file that we're interested in, this image.tar. So then when we get down and we're actually inside of the workflow itself, we can see our workflow is named scan image. It consists of a couple of jobs. The first job is the one we defined up above here, our Docker build and save, right? So that just builds and saves off our image. And then our TwistCLI scan image job that comes from the orb picks that up. You can notice that it has this great dependency behavior built in. And I'm coming from Puppet, where, doing config management of resources with dependency graphs. That's just like near and dear to my heart to see this kind of cool requires type thing in here. So this make sure that happens before we ever do this. And then I'm going to pass in a few things, right? So you'll notice I have a context here. I have my image and the image tar, and then some settings for my thresholds for my scan. So to break those things down a little bit, I think image and the image name, right, and the image tar itself those are pretty self-explanatory. This is that tar that I stashed in that workspace, and this image name is the name that we actually want, the image tag that we would have on that image itself. The context, I probably, hopefully folks are familiar with the context, but that's another great feature that's built in. And so if I kind of go over and look at my context. So here I am in my CircleCI app view here on the web, and I've got one context set up, And this is I call it my Twistlock scanned context. And in here, I've got just 3 pieces of information, key value pairs. So these are going to be used by my orb. So I've got my Twistlock console URL. So this is, again, that you saw in the overview architecture. The console is that thing that we need to talk to, both in order to receive our policy information and our threat information to do the scan with, but we also want to submit the results when we're done back to Twistlock. So that's that console, and then these are our username and password credentials. Those are for a user that has a role in Twistlock called the CI user. So you don't need to use an admin user or some other highly privileged user. Just use a CI user that's built for this sort of purpose. And so we're going to consume these 3 key value pairs inside of our orb. So that's essentially kind of what you're seeing here, is use this context. And then within the vulnerability thresholds, to explain that a little bit. So critical is the kind of the top for vulnerabilities or compliance. And then and then there's a kind of a range of those underneath there. What I'll probably do is just give you a quick visual here on what that looks like inside of a passing build, right? So here's one where we have a build that we scanned with CircleCI. This was pushed up to Twistlock, and you can see that we've got some things here that are at medium level vulnerabilities, low level vulnerabilities, et cetera, right? These things are determined by the CVEs, right? So these are reports about critical vulnerabilities. And these you can kind of dig in and link out to see exactly what's in that report and learn more about it. But we can also see, if this version actually has a fix that was fixed in a subsequent version of the package, we can learn what risk factors are involved, et cetera. So this is, we have these different levels of low, medium, high, and critical. And then we have this dimension of whether there's a fix available or not. So it could be that we might say, well, if there's vulnerabilities out there, but they don't have any fixes, meaning I can't really do anything about it, maybe I'm not as concerned. But, so if it's, but maybe I just can't tolerate any vulnerabilities of high or critical level. And so it's kind of up to your own organization to decide that. Similarly with compliance issues, this one happens to have a high compliance issue where we didn't create this with a non-root user. And so this is one that would be, kind of a best practice to ensure that. And so we're picking this up. But again, you can kind of set which compliance issues and things you want to ignore or you want to highlight in your configuration here in Twistlock. And additionally, of course, then your developers can get a visual here about once they want to dig in, they can actually see the actual vulnerabilities and at what layer in, for example, a Docker file, those things were introduced. So it kind of gives them that visibility. But it could also be that you just have maybe some folks on another team that use the Twistlock console, and maybe your devs are using CircleCI as their exclusive interface, for most of their work. So what would that look like? So in that situation, here, let's take a look at CircleCI and our test image and look at the workflows that we have in the history. So you can see here that my last 2 runs were successful, and I can dig into those and kind of see again how these things were composed. Remember, we had our Docker build and save was happening first, and then we had our Twist CLI scan image was coming after that because of that dependency relationship that we set up in our workflow and the order that they came in. So we can dig into any of these just by clicking on them, and you can see kind of what transpired inside of that. So including, spinning up an environment and checking out the code that I have in my repo and running our build, making our workspace directory and persisting things out to the workspace and all that, right? So all the things that we expected that we saw in our config YAML, we're seeing right here in this job. So kind of like you could imagine that these two jobs, right, are part of that one workflow run. First, we did the build and save, and then afterwards we did the scan image. So if we take a look at the scan image, we can also kind of get a view here of the things we do. And so this is where the orb is kind of taking over and curling against API for you and kind of setting up the static binary. It's also attaching the workspace that you've specified. So this is actually pulling in the workspace and kind of rehydrating the Docker tarball to make it back into an image. And then you can see here we're actually running the scan itself. And so this scan is using the vulnerability thresholds that we specify. In this case, we're using critical as a threshold, for example, and then we can see all the vulnerabilities. This is that same list of vulnerabilities that we would have seen in the Twistlock GUI, but done in a text format out here on my Circle console. And so, you know, because of the vulnerability threshold we had, we said we were only concerned if it was critical vulnerabilities, but all we've had here are low or medium vulnerabilities. We didn't have anything high or critical, certainly. So we passed there, and we similarly were only concerned about critical compliance issues, but we only have a high. So we passed there. So if you kind of slip under that bar, you're good to go. And then this workflow overall succeeded. And it could be that you decide, you know, we actually need a more stringent control on this particular project. So for test image, maybe we want to actually change that bar a little bit. So I'm going to go in here and actually edit this. This is going to look very familiar to folks, right? There's our Docker build and save that's happening up there, that job that we're defining right here. And then we actually go down here and we can see our inputs again to our TwistCLI scan image from our orb. So I can go ahead and just modify these. And let's say actually for vulnerabilities, we care about medium or higher. So this is going to trigger for medium, high, or critical. And then similarly, maybe I care about high for compliance. So that'll trigger for high or critical. If I put low here, it's going to trigger for anything, right, that comes through that's low, medium, high, or critical. So then I can kind of make a commit there and say, you know, let's ratchet down our vulns, and then I'll make a commit. Now, because I've got my .CircleCI with my config.yaml in it, we're actually going to kick off a run over here. So let's go over to my workflows and let's look at the jobs even. You can see actually we've got our Docker build and save is running right now. That was triggered by my push, the commit that just happened. And so we can even dig into that and you can see it running live. You can see it's actually right now in the middle of persisting it to the workspace, and it just finished that. So it did all the things that we would expect. So let's jump back over here just to see if we can catch it in the middle of running our TwistCLI scan, which it's doing. So we'll dig into that. And we can see right now it's creating an environment. And we'll talk about this in a second, right? So it's using an executor to do that. And so we actually specify a real simple default VM executor in our orb. Oh, and I see some red. Okay, so we see some red and we kind of expected this, but let's think about why, right? So now our vulnerability threshold is just medium and our compliance threshold that we set was high. So let's see, we got the same list of vulnerabilities back, but of course we have a whole bunch of mediums. And because medium is now a fail, our vulnerabilities failed. And because we set our compliance threshold to just high or worse, and we have a high, we got a fail there as well. So overall, we get a fail. And so therefore we see, even though our build and save succeeded, our scan failed. Therefore, our workflow for test image kind of overall is currently in a failure state. And this is where I'm going to probably have an email in my account. I think I have it set up right now to send me emails, and I have an email that's saying, "Hey, scan, your test image has just failed, so get on it," right? And so I could be getting those alerts from Circle directly, and of course I'm going to see this same thing if we take that full. Let's take a refresh here, right? So right now, our last 2 times that we saw from Twistlock's perspective, we were passing. If I refresh this, now we can see our failure, which coincides with that same failure that we saw over on the CircleCI side of things. So, everything really, really in sync between CircleCI and Twistlock. So no matter where folks are looking at this, right? If somebody lives mostly in Twistlock during their day, doing general DevSecOps, cybersecurity type functions, or if they live more in the CircleCI interface and are working with workflows and using orbs and all that sort of thing, either way, you're going to have that single source of truth that you share, and can then share with others in your organization as well.
Jeremy, this is awesome.
Where are we at in terms of time? Do we want to dig into any more details? What do you think, Chris?
Yeah, great question. I think we've got at least another 15-20 minutes on the calendar.
Yeah.
Pause for questions real quick. Hopefully some of our viewers will put forth some questions. I wanted to point out, though, I think on the Twistlock page itself, where it enumerates the different vulnerabilities and CVEs, if we could go back to that in a second.
Absolutely.
The description feature is very powerful as well. I mean, it's one thing to say, hey, look, you've got a vulnerability. This is the corresponding vulnerability level, but it's another thing to talk a little bit about why this is a vulnerability and specifically the remediation path.
Absolutely. Yeah. So, just to give folks a sense of that. So like this, we have a very global view of what's happening in the environment. And so you're going to, every time we see, let's talk just about containers. We'll set aside serverless and hosts for a second, but if you just think about container images, whenever we see it in CircleCI, we see it sitting in a registry somewhere, we see it, someone even just did a Docker run, and it's running now on a host somewhere. We're going to scan that image and we're going to develop a complete manifest of everything inside of it. And then as we're getting new intelligence from our intelligence stream, we can quickly know whether that new vulnerability that just occurred in the world, whether it affects us or not. So we're able to kind of constantly apply up-to-date info. In our case, we can also, and this radar view is kind of an overview in our right here in this environment that I have of all the different microservices that I happen to be running in Docker and Kubernetes and different things like that. And then you can dig into anything that you have and you can see what vulnerabilities there are, what compliance issues. And of course, we're also learning about the runtime behavior of these things and can also learn, what processes should be running, what's normal around network and file system. And we can show you, variants from that. But within vulnerabilities, you can dig right in, and in this particular image, we can see some vulnerabilities that exist. This one happens to be something in, here's a good one here that's in Node, for example. So this is the tough cookie package. Here's the vulnerability that we're talking about. In this case, we're running tough cookie 2.3.1, but there's a couple of vulnerabilities associated with it, and they happened in this case to be fixed in 2.3.3. So that's something that we could definitely get on, right? It might be that we look at that and we're saying, oh wow, why am I, do we really need to have this version? So that you might say, well, let's go ahead and bump up to 2.3.3 and then let's run it through our CircleCI workflow again, right? And if it comes up green as far as the actual functionality and our tests, then Twistlock's also going to say it's green from a vulnerability perspective. So now you've just kind of closed that loop and remediated something that could have had some impacts, right? It could be that you could suffer from this, high severity denial of service, threat vector. But instead, now you've picked it up, you kind of stopped the production line there, and because in this environment, it was important enough for you to do that. It could be that in some environments, this denial of service attack wouldn't actually affect you. And so you could say that, well, you know what, this exact CVE right here, I'm not actually going to be affected by this because, perhaps you're not in a network environment such that you're worried about that. Who knows, right? Whatever your case is. Well, you can go over here and you actually set up different policies for vulnerabilities within Twistlock. So you could actually say that I want to ignore certain CVEs, for example, right? So I could say that, this CVE is one that I'm going to ignore in certain environments, right? In either certain images or on certain hosts. Somehow I'm going to ignore those things, right? And that's maybe a place where you could kind of remove that off the list. But in general, you could also just fix it at the source. So that's kind of gives you a little bit of a sense of that kind of round tripping that you could do when you detect a vulnerability. First at Circle's level, telling you, hey, stop. Maybe we need to change what we're doing here. And then you can, make that decision and memorialize it actually in the tool so that it's then, enforced going forward.
Well said. A couple of thoughts there, though, just in terms of the integration between Twistlock, CircleCI, and then, of course, if you're using CircleCI, we integrate tightly with your VCS, be it GitHub or Bitbucket. So if nothing else, you're going to get a build notification to GitHub that says, hey, my build failed, right? With a link back to the build page. And then from the build page itself, you can see the results from the Twistlock scan. A couple other things come to mind. Email notifications. You could potentially invoke the Slack orb. You can get a Slack notification that says, hey, my build failed. This is why. This is what the remediation path looks like. So those are just a couple things that come to mind. Can we go back to the radar page? That seems super interesting.
Yeah, absolutely. So let me pull that up.
I feel like we were looking at a network mesh in a Kubernetes pod.
Oh, right. Yeah. And
that's pretty cool.
Yeah, actually, just because you said that, I just felt like I really wanted to open my email. Not that I want to do any work right now while we're hanging out, but what I want to do is bring this up really quick.
Awesome.
Yeah, this is what I got just a second, 7 minutes ago when this workflow failed, right? So again, pretty cool. I love this detail too, where I can see that, oh yeah, my Docker build and save, that's fine, but scanning image, that failed. So right, gives you that, and shows me exactly why, right? I actually ratcheted down my vulnerabilities, right? And shows that commit, and I can link back to that. So I really, really appreciate that. I get those occasionally on my phone. I'll look down and see an email from CircleCI. I say, oh yeah, let me go fix that.
That's awesome. In terms of the Twistlock scan CLI, is all of that output just streamed to standard out?
Yeah, absolutely. Yeah, that's all the standard out. So then if you wanted to do anything else, any other kind of processing
rep, set,
on top of it,
awk.
Yeah, whatever you want to do, absolutely go crazy with that. And of course, you can get this info back via our API as well. So when I showed you, either scan reports or vulnerability reports, you can get that via the API, or you can even download a CSV from the GUI if you want to do some further processing.
Okay, now we're talking. Yeah. And then you can obviously throw that into a spreadsheet and okay.
Yep, throw a pivot table on. I don't know, go crazy.
Yeah, exactly.
Yeah, and so we're back at that radar view, Chris. But yeah, indeed, this is the madness, right? That is we're all dealing with our microservices environments. But yeah, making sure that before anything gets here, like you see a lot of red in this environment, because this is my demo. I want to show people a lot of vulnerabilities, but hopefully if you had CircleCI involved and you had your orb working with Twistlock, then most of what you actually had out here would be more like these guys in green, which is what we're going for.
This is awesome. Can you speak to the architecture of this just for a little? How do we get such a beautiful view?
Oh yeah, this is pretty cool stuff. So this, our radar view is automatically generated. So what we did in this case is we're observing all the microservices that happen to be in my environment. And what I actually did here, so here's an example of this classic app, the Sock Shop app from Weaveworks that they've graciously provided the community that shows kind of a typical microservices app for a web store. And we see like all these connections between things, right? So we didn't draw any of this stuff out. This is all learned by Twistlock observing the traffic between these microservices. So, and it doesn't matter that, maybe some of these containers are running on one host and versus another in their Kubernetes cluster. We're able to, where Twistlock sits in that architecture, we sit as a privileged peer container that's right next to these containers. So we didn't have to modify any of these containers to instrument them with Twistlock. We didn't have to modify the underlying host and add in some kernel module or something. Some of the solutions out there do that sort of stuff. We don't run any extra processes, right? We're just a container. Just our Defender container sits there. We're able to observe the underlying file system, network, and process activity. And then we can determine, we could see a packet kind of going out from one container and then getting received by another one. And we're able to then discern, what that layer 3, if you will, relationship is that's going on. And we don't have to put in IP addresses, which are going to be changing all the time in a container environment. And so it makes it really, really scalable. We just generate this automatically. And similarly, we look at what's happening inside of all of these guys, right? So if you kind of look inside of every container, including the Twistlock console, right, is again just a container. So I can dig into the Twistlock console here and see that there's some processes. This is like the entry point process, but then that spawned off a bunch of MongoDB processes. It did a bunch of networking things that we expected it to be listening on Mongo, but we also saw that it started listening on these other Twistlock ports to do the Twistlock service, and that it reached out to 443 to pull down intelligence stream data, right? To make sure it's got the latest and greatest. And then we also saw that it hits certain parts of the file system, et cetera. So all of this was learned in like a 24-hour learning period. Now that this is an active model, we're enforcing this. So if anything else happens, like if we hit any other part of the file system, or if we go out to some strange place, strange DNS name on the network, or we try and talk to a different container than we're supposed to, run a weird process, all of that is going to trigger at the very least an alert that's going to allow us to know that, we call those container audits. So something strange happening around file system or network or process. And then we'll actually be able to roll those things up and into incidents where we can say like, hey, based on the pattern of activity that we're seeing here, I'm seeing some crypto miners or some lateral movement. Somebody's trying to do some they're doing some end mapping across, or looks like some port scanning. They're trying to do, maybe somebody's doing some data exfiltration, where why are they reaching out to GitHub all of a sudden to pull stuff when this is supposed to be an immutable image, right?
Right. Good example.
Yeah, you can dig in and even see what was running there. Like, how come that person's like copying out the Etsy password file and shoving that into ix.io's like paste bin site? What's that all about, right? So you could start to see forensics, and it gives you that kind of, there's a whole lot in here. Firewalls, again, all these different things that you can do, cloud native firewalling for your container environment. So that's why we say it's that end-to-end thing, right? So certainly runtime is really important, but if you just kind of take that very important step and make sure that in CircleCI, in the early stages, that you're building images that meet your standards for security and compliance, and don't let things out in the wild that are going to bite you later, you're going to be in a way better posture for security.
Certainly. Definitely want to pause for questions, encourage some of our viewers to, put forth questions, any questions. But I've got a couple more questions for you, Jeremy, in relation to intelligence streams. Let's talk about those for a second. What are some of the intelligence streams? How do you get information from the intelligence streams? How do you aggregate some of that information and then get it into Twistlock?
Yeah, definitely. So I mentioned before that there's over 30 different sources that we're aggregating. And some of those things are, there's certainly some open source things, right, that anybody can take advantage of, like things like the National Vulnerability Database is where a lot of these vulnerabilities that have been announced out to the world are at. There's also, like I said, some data from our different OS vendors, right? So from Microsoft and Red Hat and Canonical for Ubuntu things, et cetera, as well as everything from, you know, Oracle for Java, Python, Ruby, Node, you know, all these different providers. We're looking at all the different vulnerabilities that they're talking about and announcing. Additionally, we're pulling in information from, like I said, some kind of boutique providers that we work with and have relationships with. They give us things like lists of IP addresses and domain names that are known to be problematic, as well as our own Twistlock Labs research, where we do things around, you know, we found some critical 0 days and publish that out to the community. So we'll, you know, if we find something like that, that's immediately going in our intelligence stream and protecting our customers, and then getting, you know, published out to the community as well. We found actually a lot, and our Twistlock Labs team does a lot of research around this, and so we published some great information you could check out about, you know, the latest kind of Kubernetes vulnerabilities that have been out, then runC vulnerability that was announced recently. So those more areas where we do research. And we also kind of, so there's kind of vulnerability sources, but there's also things around compliance, right? So within compliance, that's an area when you're setting up your compliance policies, where again, we do a lot of research. And so when you're setting up your policies, we give you over 300 different compliance checks. So you're talking about, you know, 30 different sources just for vulnerabilities. And we also give you all these different sources for compliance. So things like Docker CIS and Kubernetes CIS benchmarks, the Linux CIS for underlying hosts to make sure those things are secure. And then, you know, things like Istio. I know people are talking about Istio service mesh, first of a kind Istio compliance checks that we've added in to make sure that you've actually got things set up in a best practice secure way within that service mesh. And then there's some, like I said, custom, you can make your own custom compliance checks, like run a shell script that will check for something that's important in your organization. And then our Twistlock Labs team, you know, always contributes more. So we make sure that we've got some compliance checks that don't really fall into any particular category of those others, like CIS, but, you know, things that we've learned you know, the hard way in the field, making sure you're using the latest images, not old crufty images that happen to be hanging around. Yeah. No malware or crypto miners inside of things. And that's something that we check both at the image level, but we're also going to watch that in runtime to make sure we don't see activity like that. And then making sure you're not embedding in secrets or private keys or other type of information. We want to, you know, so those are things that we've noticed can really bite people. And so we want to make sure that we're helping them with that. And because there's 300 different checks here and it's hard to know how to flip all these bits, we provide some predefined templates for things like GDPR or PCI or HIPAA, or again, that NIST special publication 800-190, right, that our CTO helped co-author on container security. So we find that, you know, that helps people get started with a single click, and then they can make sure they're in a good posture as far as compliance, vulnerability. Again, the runtime, the radar, and all the runtime behavioral stuff just kind of takes care of itself. You can tweak it, but it all works just out of the box automatically. So pretty quickly, you just basically install Twistlock, and you've just really increased your security posture tremendously.
Significantly.
Yeah.
I'll tell you, you know, my experience on the SRE team and the work I did with FedRAMP, I was certainly familiar with a lot of the container scanning functionality. A lot of this, though, is new to me, honestly. The radar feature, just the granularity with which some of the CVEs are presented, excuse me, I think is really, really powerful.
Yeah, oh no, I appreciate it. And yeah, but you know, it's funny, like, again, like people ask me, you know, where do we get started? And, you know, certainly we've got, you know, we've shown the Twist CLI scans that we're doing here. When you look at all these images that I happen to be running, and they've all got a lot of vulnerabilities because I'm trying to show that sort of thing. But we'll also help folks by saying, you know, a good place to start is we have a top 10 list here. So here what we actually do is we combine together the static factors of the image itself that we're scanning for, right, like we've been doing with CircleCI Orb. But then we also are combining in the runtime factors to give you a composite risk score. Because, you know, it's one thing about the potential risk of something, but how are you actually running it? Is that risk realized? Is it exacerbated by the way that you're running it? So in this particular case, this libx11 vulnerability has got, you know, it's a network attack vector, it's easy to do, and, you know, it's remote execution and critical and denial of service. It's got a lot of network and remote execution issues. So if you actually had a container running with listening ports and that's running as a very privileged user without a lot of security profile applied, this could be troubling, right? Well, guess what? We've got 1, 2, 3, 4 images that suffer from this, and they're running containers on hosts. In this case, we have one that's in red here because it's got the trifecta. It's got all the running problems as well as these inherent static risk factors. So this is one that we, given how many of these containers you have, which ones are affected to what degree, then we, rank this one relatively high in terms of a risk score. So this would be a place where you might say, wow, let's attack this one, right? And let's burn down all the things in the 90s maybe, and then work on the 80s and so forth. Yeah. So, and as opposed to seeing a sea of red and not knowing what to do, right? Throwing up your hands.
Well said, Jeremy, well said. Well, we're almost out of time here. No questions, but I've got one final question for you. How did you become so versed in InfoSec?
Oh, wow. Well, it's interesting, coming from the DevOps side, security was always, oftentimes security was our customer as well, right? So it was typically developers or operations teams, DevOps teams, but then security always played a role, right? And so part of the reason for doing things like, configuration management in the old days was to lock down things, right? To lock down things so that you wouldn't be vulnerable to security issues, or even just, you're coming from the SRE side, good old fashioned patching, right? Just making sure all your systems are patched, essential, right, to security. Yeah. So, I think I got exposed to things that way. And then it's been a fire hose working at Twistlock. I get to work with some of the greatest, like I said, we're with a quarter of the Fortune 100. We get to work with some really amazing customers who have really significant challenges, and we get to help them with those. I also get to work with amazing partners, like the folks at CircleCI, and developing, cutting edge integrations and things. So I think it's just like this market, this cloud native landscape. Everyone's seen that, the CNCF landscape slide. I think I looked at it first time, a few years back, and it was very digestible at a glance. Now it's quite an eye chart, right? So I think the best thing to do is to just dive in with both feet. But if I was going to tell anybody about how to get started, I would say first thing you can do is, just get your CI instrumented with security, right? And it's super easy, like we saw, especially with Circle, and you're going to reap benefits immediately from that.
Definitely. Definitely. Well, Jeremy, thank you so much. This was amazing. Hopefully looking forward to another one in the future.
Absolutely, Chris. Yeah, love working with you guys.
Yeah, appreciate it. Well, I hope you have a great rest of your day. And thank you all for watching. Talk soon.